Okay, so we just looked at a story that was talking about a particle. So let's read it again. It says the position of a particle moving along a coordinate line is, and so here is the equation that they have given us. S is in meters and T is in seconds. So always a good idea to write that down, right? S is in meters, which means a distance. T is in seconds, which means a time, right? They would like us to find the rate of change of the particle's position at t equals 5 seconds. So here's the deal. The first line basically gave us this equation and they told us what these particular variables represented. The second line said find the rate of change. And as soon as they say find the rate of change, that means you've got to find the, that's right, derivative. So here we go. You're like, not again. Of course again. So S prime of t, right? Because that really is the function. I'm taking the derivative of S with respect to t. And actually, before I do that, I am going to do just a little rewrite on the original equation if you're okay with it. So the original equation, S of t, is equal to 29 plus 4t to the power of what? Because I don't like that square root. Good, to the 1/2. Now this will make it a whole lot easier to find its derivative. So the derivative of this particular function, how do I find it? Good, power comes down. And then, good, reduce the power by 1. And then what? Yeah, and then you have got to multiply this by the derivative of the inside. So the derivative of 29 plus 4t. So what would be the derivative of 29 plus 4t? Good, I heard ya. 4. So we've got 1/2 times the parentheses of 29 plus 4t to the negative 1/2 times 4. Excellent. Now, let's see what we can do to simplify this. Notice we've got the 1/2 multiplied by the parentheses and multiplied by 4. So couldn't I do the 1/2 times 4? What would you get? Good, you just get 2. So this derivative would just be 2 times the 29 plus 4t to the negative 1/2. And what's that negative exponent imply? Yeah, this guy goes to the bottom. So this is going to be 2 over that square root of 29 plus 4t. Excellent. Good. Got it? Okay, now, it didn't just say find the rate of change, which we did. This is the generic rate of change. But it was very specific. It said find the rate of change of this particle's position at t equals 5 seconds. So what do you have to do to find the rate of change when time is 5 seconds? Good, you plug in the 5. To where? The original problem or the derivative? Yeah, the derivative, because it said the rate of change at 5 seconds. So now we have got to find the rate of change of the position of this particle at 5 seconds. And so we're going to have 2 over the square root of 29 plus 4 times 5. So what are we going to get in that denominator? Yeah, we're going to get 2 over the square root of 49, aren't we? Which is just 2/7. So, the rate of change of the particle's position at the 5-second mark is 2/7 meters per second. And if you change this into a decimal, you're wrong. Why? The directions asked you to type an integer or a fraction. So be careful of the directions, okay? All right. So nothing new, really. They're asking me to find the rate of change, so I've got to find the derivative. So here was the generic rate of change. And then they were very specific and said, well, now find it when we're at the 5-second mark. And so here it is at the 5-second mark. Cool? Okay, stay tuned. Got another. Okay, back with another one. Let's read it. Given a total revenue function, R of X, which looks like that, and a total cost function, given here, both are in thousands of dollars, they want you to find the rate at which the total profit is changing when X items have been produced and sold. So they gave us a revenue function and a cost function, and they're talking about profit, right? Okay, so if they're talking about profit, let's get that out of the way first. How do I find profit again? Yeah, to find profit, you got to take the revenue and subtract the cost. Okay, just making sure we got that. So let's see. They want you to find the rate at which the total profit is changing. So what are they asking you for? Yeah, they want the rate of change of the profit function, right? Because they said find the rate at which the profit is changing. Rate changing, changing rate. Profit function. Need to find the derivative. Cool? Yeah, it's not really any different than the last problem, is it? They want a rate of change, but now they want it with respect to the profit function. So that means we have got to find the profit function. All right, so this is how we said we find profit. So let's see what this looks like. To find the profit, I'm going to say, whoops, I got a little ahead of myself. To find the profit function, with respect to X, we are going to take the revenue, which is 900, and times the square root of X squared minus 0.3X. And now we have to subtract the cost function, right? Well, the cost function is an addition problem, which is why I set up a bracket here to make things a little bit easier for us to see, because we're going to have to, we're going to have to distribute that minus sign, right? Okay. So do you mind if I change that square root? Yeah, I want to change it to a power because we know we have to find the derivative, and I'd rather the square root be a power because I don't know how to find the square root if it's not a power. So, x squared minus, see, my brain likes to add, and this is why you guys need to do it with me, minus 0.03x raised to the 1/2 power minus 2,000 times the parentheses of x squared plus 5 to the 1/3 minus the 800. Agreed? Okay. And now that we've got our profit function, now it's time to find the rate of change, which means we've got to find the derivative. Lovely. All right. Take it slow, one step at a time. Don't try to do 2 steps at once. All right. So 900. We have to bring the power down. Agreed? And then we reduce the power by 1, which gives us a negative 1/2, don't we? And then we have to take the derivative of the inside here, don't we? Okay, so I admit it. I'm going to have us do a second step right here, right away. What's the derivative of the inside? Derivative of x squared is what? Good, 2x. And the derivative of 0.3x? Good, just 0.3. Good job. Knew you could do it. That's about the only time I do like 2 steps in one. Okay, so minus, we've got this 2,000. We bring down the 1/3. We reduce the power by 1. So what's 1/3 minus 1? Good, negative 2/3. And yes, we have to take the derivative of that, which would just be what? Good, 2x. And then we have to take the derivative of this 800. So minus what? Yeah, 0. So I'm not even going to worry about the minus 0. All right. Let's see what we can do about simplifying. the derivative of the profit function. So 900 times 1/2. Good, that's 450. And in parentheses, we still have x squared minus 0.3x, still to the negative 1/2 power, right? Times this 2x minus 0.3. And over here, oh, this is looking rather fun. So I've got 2,000 times a third. Well, that's just going to be 2,000 over 3, right? Times another 2x. Yeah, so that's going to be 4,000x, right? 2,000 times 2x divided by 3. And then we have the x squared plus 5 to the negative 2/3. How's it going? We on the same page? Okay. Let's see what more we can simplify. So, I don't want to have the negative exponents there. So where do these negative exponents tell me this is going? To the bottom. And this negative exponent? To the bottom. So we have 450. This guy doesn't have a negative exponent, so it's going to stay up top. Over, yeah, that was a square root, so it's going to remain a square root. X squared minus 0.03x. And now minus 4,000x over 3. Yeah, this negative goes on the bottom. Well, the 3 is already on the bottom, so this is going to go next to it. So it looks like the cubed root of x squared plus 5 to the power of 2. And yes, I can distribute the 450 if I want. So, these denominators aren't the same. So there's really not a whole lot more I can do with this. Such a lovely little profit function. But there it is, right? They didn't ask me for a specific number of items that were produced and sold, right? They didn't say find the rate of change of the profit when a certain number of items were produced and sold. It just wanted me to find the rate of change of the profit function in general. Well, there it is. As lovely as that looks, there it is. Cool? Okay, got one more story for us. I'll be right back. Okay, I'm back with the last problem. Let's look at it again. I know you've already read it, but let's look at it again. If $700 is invested at an interest rate I, compounded annually, in 4 years it will grow to an amount A. And capital A is given by this particular equation. Good? This particular function. Okay, so remember, A is the amount to which it's going to grow. I is the interest rate. So let's write those down. Okay, I is the interest rate. And A is the, I'd say the balance. It's the amount it's going to grow to. So that's the balance basically, right? Okay, so let's look at part A. Part A is asking for the rate of change. Well, if it wants the rate of change, that means we need to find the derivative. Nothing new. The only thing that's new, so to speak, is the equation or the function they give us to find the derivative of. Sometimes it's a simple function and sometimes it's a little more involved, like that last one with finding the profit, right? Okay, so the derivative of A with respect to I. So what's the first thing we do? Write the 700, bring down the power, reduce the power by 1, and then take the derivative of, with respect to I, of the inside, right? Don't put x there because this isn't an x, this is an I. So derivative with respect to I. Okay, and so this is going to equal, yep, that's 2,800, right? 1 plus I, the whole thing to the power of 3 times, what's the derivative of 1 plus I? Yeah, just 1. So the derivative of A with respect to I is going to be 2800, 1 plus I, the whole thing to the power of 3. Cool? Good. Now, part B, they're like, what's the meaning of part A? Okay, well, the meaning of part A is this. This is the balance. Pardon me. See, I wrote myself a note because I wanted to make sure I wrote it correctly. This is the change of the balance in account A as the interest rate I changes. It's the rate of change. So as I changes, A is going to change. Cool? Okay, so you guys have fun with this stuff, and I'll catch you on the flip side.